Now we're going to talk about the graph of radical expressions. Graphs of radical expressions. The first graph we should talk about is y equals the square root of x. This is known as the parent function. The reason it's the parent function is because the math model is a times x minus h plus k. This is the math model. For it to be a parent function, a must be 1, h must be 0, and k must be 0. So you can see here that the parent function is basically the stripped down version of the math model. Okay, it has a 1, it has no h, and it has no k. There's 0. Okay, so we want to graph the parent function. Well, there's a few things we should note first. One of the first things we should note is that the vertex of the equation, the vertex's x and y coordinates are at the address of the variables h and k. So notice that the x coordinate is h and the y coordinate is k. The thing we should be careful of is that the math model calls for x minus h. So what you want to do is you want to use the opposite of whatever sign is here, because if this is calling for x minus h, so if we have something like x minus 3, what we want to understand that the math model calls for x minus, so this 3 is really a positive 3 for h. Okay? K stays the same, but h we have to be careful of, and we want to use the opposite value of it. Okay, so from here, what we want to do is we also need to define the domain and the range. The domain of the function is all real numbers greater than or equal to h. So the way we do that is we want to write h first, and then we want to write infinity going positive. Because remember, we cannot take the square root of a negative number, so what we want to do is we want to take all of the numbers that are h's value or greater. And you'll find out why as you try some of these, that h has to be the lower limit. Okay? And that's the domain. The range of all of these functions is special. The range is affected by the sign of a. If a is negative, then the range goes from negative infinity to k and stops. And if a is positive, then the range goes from k to positive infinity. So those are the special things about the math model. And now what we're going to do is we're going to graph the parent function, and all of the equations should look somewhat similar to the parent function. So if we were going to graph this, what we should note is that a is a positive 1, that h is 0, and that k is 0. And now that we know that a, h, and what the values of a, h, and k are, we can graph it a lot easier, because we can make an easy table. So what happens is we're going to make an x and y table, and we want to use smart, intelligent numbers for x. We want to use numbers that we can take the square root of. Now we know the square root of 1 is 1, so y is 1. If we put in x is 4, we get the square root of 4 is 2. And if we put in 9, we get the square root of 9 is 3. So our graph is going to start at 0, 0 at our hk, which is 0, 0 for this problem. And then if we go over x is 1, we get a point. If we go x is 4, we get the next point. And if we go over to 9, we get x is 3. And so we get this graph of the radical expression. Let's try another one. So the next problem I want to try is 1/4 of the square root of x. Again, we should make an x and y table. We know if x is 1, that y is 1. We know if x is 4, then y is 2. If we know that x is 9, then y is 3. Okay, what we're going to do though is we still have to multiply each of these square roots by this amplitude, 1/4, a. So what we're going to do is we're going to write in 1/4 the square root of x, and we're going to write it down the new number. So it's going to be 1 times 1/4 is 1/4, 2 times 1/4 is 2/4 or 1/2, and then 3 times 1/4 is 3/4. So when we go to graph it, again what we're going to do is here we can see that x is minus 0 and plus 0. So h is equal to 0 and k is equal to 0. So that is our starting point, 0, 0. Then what we do is we're going to plot at 1, 2, 3, 4, 5, 6, 7, 8, 9. What's happening is at 1, y is 1/4. So we want to plot 1, 1/4. At x is 4, y is 1/2. So when we go out to 1, 2, 3, 4, we should be at about 1/2. And when we get out to 9, we should be at 3/4. So what's happening is this is a really flat square root function. And that would be the graph of the function. Let's try another one. Let's try the negative 1/2 square root of x. And again, I would start with an x and y table, just to make your life easier. So again, if x is 1, y is 1. If x is 4, y is 2. If x is 9, y is 3. Then what we do is we multiply that by the negative 1/2. So we get negative 1/2. We get 2 times negative 1/2, which is negative 1. And we get 3 times negative 1/2, which is a negative 3/2. And now what's happening is the negative is turning the graph upside down. So what we want to do is we want to be careful that we change the way that we set up our line. We again have h is 0. And k equals 0. So we have our starting point at 0, 0. And then when we go out 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to go down 1, 2, 3, 4. Okay, now what's happening is at x is 1, we get negative 1/2, so we would be here. At x is 4, we would be at negative 1, so we would be here. And at x is 9, we would be at negative 3/2, so we would be here. And again, you can see that this is a really flat graph opening out to the right. You can also see here that our domain starts at h. See how it starts at h? It starts at the x value. And it goes to positive infinity on the x-axis. We go out that way. And then the range, because a is negative, our range would be, it's going to be going down to negative infinity. It'll take a long time to get there, yes, but you will get there eventually. So what will happen is we'll start at negative infinity, and we'll be coming up, and we'll terminate and stop right here at k. And that is 0 in this problem. And that is how you define, it's how you graph a radical expression and define the domain and range. And let's try another one. Okay, let's try this. X minus 1 minus 2. And what we're going to do now is, because our domain is going to go from negative, it's going to start at negative 1. Well, is it going to start at negative 1 or is it going to start at positive 1? Remember that this is part of the math model. And what we want to do is we want to understand that h is positive 1. And it's going to go to positive infinity, the domain. So when we set up our x and y table, we want to start at a number that's 1 greater than this. Okay? Because if you put in 1, you're going to get 1 minus 1. So check it out. If you put in 1, you get 1 minus 1, which is 0. So you get 0 as a result. Well, or do you? You get 0 in here. You get 1 minus. So let's change the way we're going to do our table. It gets kind of confusing if you leave it like this. So you're better off doing it like this. Okay, and what we're going to do is we're going to start with this first number. If we put in 1, we get the square root of 1 minus 1 minus 2. So that's going to be the square root of 0 minus 2 would be minus 2. So our starting point is at 1 negative 2, which which happens to be h and k, the address of our vertex, which is where we should be starting. Then what we want to do is we want to put in 1 unit over. So if we go 1 unit over from 1, we go to 2. And if we put in 2 minus 1 minus 2, we get 2 minus 1 is the square root of 1. Minus 2 is 1 minus 2 is negative 1. So we get 2 negative 1 as an address. So this is plus 1. And now we want to go plus 4. So if we put in 5, we get the square root of 5 minus 1 minus 2. 5 minus 1 is 4. The square root of 4 is 2 minus 2 is 0. So the next address is 5, 0. And if we do the same thing for 9, well, we don't want 9. What we really want to do is we want to add 9 to 1 so we get the square root of 3 is the trick. So we're going to add 9 to 1 and get 10. And we get the square root of 10 minus 1 minus 2. That's going to be 3 minus 2 is 1. So we get the address 10, 1. So let's look at the picture of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're going to start at -2. And we're going to go as high as, I think, just 1 or 2 or 3. The idea here is that we're going to start at 1, -2. So x is 1, we're going to be at -2. This is the value of h and k. So notice that this is a positive 1 and a -2. It matches our vertex. Then what we want to do is we want to plot the next point, which is at 2, -1. Then we want to plot our next point, which is at 5, 0. And then we want to plot our next point, which is at 10, 1. Now, I may make this look easy, but the reason I'm making it look easy is because I'm doing it in order. So it's really important that you follow the order that I'm going in so that it makes it easy for you too. So that is our graph of y equals x minus 1 minus 2. So, okay, here's the domain, but we didn't define the range yet. You can see that the range is going to, which is the y value, right? The y value is on the y-axis. It's going to start at -2 on the y-axis, and it's going to go to infinity. It's going to keep going up. Eventually, it'll get to infinity. So what we want to do is we want to say our range, because a is positive, is going to start at k, and k is equal to -2, and it's going to move on to positive infinity like that. Okay, let's try one more, just for fun. And the problem that we want to try is x equals, and this pen isn't the right pen. I want to try this pen. Use this one. So letter E, the last example I'm going to do of these is y equals 1/2 the square root of x plus 3 plus 1. And what we want to do is we want to understand here that a is equal to 1/2, that because this is x minus, this has to be -3 for it to be a positive. So h is equal to -3, and then k is equal to +1, whatever this number is. Then we want to make an x and y table. But when it gets involved like this, you want to put the equation that you're going to be evaluating in the middle. It just makes your life easier. And then put the coordinates of x and y that come out of the evaluation. So we want to start with, if this is +3, what's happening is we want this x plus 3 to be greater than or equal to 0. This is our domain. This is where we get the domain, is we take the value that's underneath the radical and we set it greater than or equal to 0 because we can't take the square root of a negative. If we subtract 3 from both sides, we get x is greater than or equal to -3. So that's where we want to start, is at -3. And what happens is when we put the -3 in, we get 1/2 of -3 plus 3 plus 1. Well, -3 plus 3 is 0, so the square root of 0 is 0 times 1/2 is 0. It's 0 plus 1 is going to be 1. So that's why the equation almost always starts at, hk, which is the -3 and the +1 here. Then what we want to do is we want to add 1 to it, we want to add 4 to it, and we want to add 9 to it, so we get a nice clean square root out of this part of the problem. So if we add 1, we get -2, If we add 4, we get positive 1. And if we add 9, we get, to negative 3, we get positive 6. The cool thing about this, or the smart thing about this, is we get 1/2 of, the square root of 1 is 1, plus 1 is going to be 3/2. The square root of 4 is 2, so it's going to be 1/2 of 2 plus 1, so it'll be 2. And then it'll be the square root of 9, which is 3, plus 1, so that'll be 1.5, plus 1 will be 2.5, or 5/2. So these are our values. The 1, 2, and the 6, 5/2, like that. So we know what the domain is. We can see that the range starts at positive 1 and it's just getting bigger. So our range, because A is positive, is going to go from our K value, which is 1, and it's just going to get bigger and bigger and bigger, so it's going to go to positive infinity. So this is our domain. X is greater than or equal to negative 3, but we don't write it like that. What we do is we write the domain as negative 3 to positive infinity, like that. That's better. Okay? So when you write you evaluate the domain by doing it the way I had it set up here, but you actually write the answer like this. This is called interval notation, and this is what's appropriate from this point forward. So now we want to graph it. Okay. So our graph, we know is going to start at 3, 1.